Welcome back to another episode of Josh's Engine Rehab. And if you're new here, this is where you listen to a grown man talk about how the government is out to get him, all while he isn't taking his court mandated medications. And if you don't know, I'm Josh. I'm that guy right there. And I have a friend with a problem. This is a cylinder head off of a 1956 Mercedes 300 SL. And my boy calls me up and he goes, "Hey Josh, I like driving this thing. It's been to Africa, it's been to Europe. But this thing lives down the street from you, and you know, I might have a bit of a problem. I've got a leaky cylinder here. I think my cylinder 3 is cracked. Can you do a pressure test? Let me know what this thing needs." I said, "Yeah, I got you. Bring the thing down." And when he dropped it off, it was a bit of an oily mess, but overall, looked pretty good. But this thing, I want to spend a few minutes talking about this thing. Because, oh boy, you don't see these every day, and they are special. Though it was rebuilt 25 years ago, the man did put 25,000 miles on it immediately. Oh, and it looks like it. But overall, it's in nice shape. I'm not going to be doing a valve job. It doesn't need guides. I'm going to change the seals, clean it up, give it a resurface, and address the original issue, which was the water leakage into cylinder 3. And I'll spill the beans right. Meow. That's no good. Found your water leak, and I was literally just scraping off this rusty, crusty garbage here and found that track from, I want to say, I mean, it's corrosion, erosion, but really I think it's cavitation because this is supposed to be a steam port or a cross drill for water to flow, but when it gets plugged up with whatever this nonsense was, your boy water, he ain't got nowhere to go, so it's just going to sit there and boil and cook and cavitate and eat itself to death. It's looking for a new path, much like me. But we found our new path. Unfortunately, that was inside of the combustion chamber, so I'll have to grind this out, get her welded up, put a fresh surface on this, and he'll be good to go. Somebody had nerded out on this because some things don't look 100% kosher and original, but I'm not going to think too hard about it, like these valve springs, which very much look domestic, aftermarket of some type. I'm going to check the pressures just for funsies, but considering it's been fine for 25 years and 25,000 miles, I think it's the right spring more than likely. And there was some modification that was done to the bottom of the retainers. These are both intake retainers. Actually, no, that's an exhaust retainer. Very cool. There's actually an umbrella and a seal in there, if I could manage to get that split apart. But anyways, I'll get this thing flipped over and show you something else that's really cool about how they did the valve stem seal setup. Intake valve is 8 millimeters, not very abnormal, or it's 9 millimeters, I don't know. The exhaust valve is very Mercedes of the era. In fact, they were like this clear into the late 80s. But that's probably a 10 millimeter or 11 millimeter valve stem that necks down to 8 millimeter. Very common. If I could find my calipers. Whoa. Zero? Zero-ish. Let's do millimeters. 12? 12. 12 millimeter stem. He's a big boy. But only 42 millimeter head. Oh, there's intake valves that are that size. Come on. 49 millimeters. Wow. So there is a Porsche 911 worth of valves in this thing. Very cool. Now that 50s technology is just everywhere here, and honestly, it's probably late 40s. Post-war, wrong side of the war, but post-war technology still pretty rudimentary, and they were still able to do amazing things. Axis powers or not, it's really something. If you appreciate mechanical nerdiness, it's pretty awesome. So this is just your typical umbrella seal, except it's built into the retainer, and there is a rubber O-ring that lives inside of this retainer, which is this black seal here. So that would just go inside of that umbrella, and that would seal right on top of this exhaust valve. And all this is going to do is prevent oil from splashing up into the keepers and then running down the valve stem and then ending up inside of the engine. It's quite effective. Oil still gets in there. It's still going to puff smoke in the morning, but it honestly did a really good job of controlling oil. Now, the intake retainer doesn't have this in any way, shape, or form. In fact, if I flip this head over, it's not even going to look like there is a valve stem seal, but oh, I promise you there is. And this is technology that we use in all of the top of the line race cars, especially the ones that have so much valve lift that you could measure it with a ruler. If you've never seen the inside of one of these really rare cylinder heads, this is an engine code M198. Probably you haven't seen the inside of one of these. It's something pretty cool. Very, very Mercedes-like, as it would be. But fun fact, Datsun took the Mercedes design, ran with it. They took it to heights that Mercedes Axis powers never would have imagined. And they ran that engine clear into the late 80s, early 90s, which would be the beloved L Series. And it all started with engines like this. Now, regarding the valve stem seals, I promised you we were going to talk about these. This is the same technology that we use in all the top-end drag race engines, where the valve lift is so enormous that there's no room for a physical valve stem seal above the guide, or you don't want to take up that real estate when you honestly, instead of putting the seal on top of the guide, you can put it inside of the valve guide. I'll do my best to show this, but there is an O-ring on the inside of the valve guide. That's what this is. Very clever. Yeah. Why put it on top when you can put it inside? Life lessons for you men. Really, really cool. Now, probably not going to show you how I'm pressure testing this. I'm not exactly sure how I'm going to pressure test this just yet. I might run to the store and makeshift pressure test this with a bunch of clamps and pieces of rubber and flat bar and just block off all of the ports, and I'll just clamps everywhere, and there'll be a mess of clamps clamping things onto watery things, sealing it up, and then I could put air onto the inside of it, pressurize the system, and look for leaks. But since I don't have a clamp fetish just yet, and I'm very happy with the two, I may go and borrow somebody's pressure tester and play Legos until I get this thing pressurized, and then I can move on. I know that there's not a crack in this head. I know that there's not a problem related to a crack or possible casting issue. We found the problem on the deck, but nonsense. I'll pressure test it just for fun, because these things are kind of spendy to replace. I don't want to go through all the effort, nor does my buddy want to go through all the effort of getting this thing back on just to find that there's another issue. So do your due diligence. Pressure test your parts, inspect them before you do all your work, save yourself the trouble. It's better than not knowing. Also, replacement heads are like 40 grand. Not going to play that game. Somebody texted me on Instagram. They were like, you can buy these for $2,500 from Mercedes directly. Well, I heard about that, except I'm told that those castings are really, really problematic. We're going to use the original. Plus, we don't want to devalue $1 million car with an aftermarket replacement casting. Mercedes or not, original is best. So we're in the pickup. I've got cylinder head on the floor down here, and I'm gonna go get this over to my old shop. I'm gonna glass bead the valves, give it a quick wash, and pressure test it. Hopefully I can get that done today, and then tomorrow in the morning I will get the head welded up, resurfaced, and then hopefully on its way back together. So, busy day? I don't know. Now, I don't think I've ever shown you guys my work truck, but if any of you know what this light means, let me know in the comments also. That's the original 5.3 liter. They're such good trucks. Oh. Also, I haven't changed oil in this in like 30,000 miles. Ooh, nice day in California. Thanks, RPM. Let's see. Yeah, I don't have one of these. It's a hell of a lot better than cleaning these by hand. Whoa, that's toasty. Nice. Oh, oily. Gross. Okay. Oh, heavy. Okay. Problem here is I'm going to run out of daylight. I'm going to have to come back tomorrow. But I think I can get this clamped down. Okay, so I'm set up. This is a bit of a train wreck. I've got that piece of wood hanging on for dear life, wedging this in place because it wants to slide that away. But I'm going to plug these two holes and I can shove some air in it and verify that it's good head and start welding. Whoa. Well, I'm set up. I've got 30 pounds shoved in it. I'm not seeing any leaks other than the plate. This one's hard to see, and that plate's leaking really bad. But we are looking good. Nada. Whole lot of nada. That's good. That means I will get to do some welding. This took me like an hour and 20 minutes to get set up. What a pain in the butt. Pain in my behind. We're back at the shop, and I started prepping this for welding. I came in here and just wire brushed all of the corroded areas so I could get a better look at it and start grinding away. And then I had a concern. A friend of mine told me that these little inserts, you can see this is a different material. He told me that these are either aluminum or tin. If they were tin, that would be an issue because as soon as I lit up on it, it would have melted and I'd have to make these inserts. And what these inserts are, I don't know if you can see these little holes in there. Those are jets that direct coolant and point it towards the exhaust ports. So there's another one here that points at the back of the exhaust port here, and that's just provides extra cooling for the exhaust. But in the process of getting this thing cleaned up, I found a bigger issue. So unfortunately, ow, that's a splitter. That hurt. Oh, ow. Okay, so in the process of getting this apart and cleaned, I discovered there was a loose seat insert. Now, I don't know if you noticed those loose or those lines moving around, but I can literally grab the inside of the seat and rotate it. That's not ideal. So this just turned into way more work than I signed up for. I was really trying to avoid doing a valve job on this. I did not condemn the guides. I did not condemn the valve job, but the guides are bad enough to where I can't recut these seats if I wanted to. So this just turned into new guides, new exhaust seats, valve job, in addition to the original work that this thing needed. The more I unpeel the onion, the more problems I find. Woe is me. And this is literally what working in a machine shop is like. Never goes the way you think it would. But soon enough, this M198 will be purring right along. Running good. But I gotta get that seat out. Start welding all these things. To get this seat out, it's as simple as that. Drop a valve down in there. Anything that fits in the guide and down below the valve seat. And then you just weld these little nubs onto the seat. And it's not enough to shrink the seat, though there's some big manufacturer LS shop in Texas that is under the impression that this shrinks the seat. You'll shrink the seat if you weld it all the way around here, but these little, basically tack welds, it's not going to do a whole lot. So you weld those nubs on, that gives you something to drive on using this valve, and then you're just going to flip the seat, flip the whole head over. Something to that effect. Oh, come on. One-handed. You give it a little tappity tap tap and the seat will come out. There you go. That's your seat. Let's see if there's a number on this. It doesn't have a number. I'd say that more than likely this is a factory seat. Very unclear. Man, what a mess. That seat pocket is all beat up. Weird. You can see that the seat was beating up the bottom of this pocket. So there's these little lines or striations. That's exactly what the shape of the other side of the seat was. And it probably indicates that the seat was also spinning in here. Coincidentally, this is also the cylinder that had the water intrusion issue. Very curious. Now, I already know how this is going. I've got to make a decision on whether or not I'm going to replace the one seat or replace all 6 exhaust seats, maybe even the intakes. The right thing to do would be replace them all. But in an old textbook I had, which burned down in a fire, big fire, it said you could wrap the seat, which means you could tap the seat with a ball peen, put your finger on the other side, and if you feel it move, that tells you that the seat is loose. I've done this in the past, and it's not 100% definitive. I think the seat has to be pretty loose for that to happen. This would probably be a good situation for that to happen. So, let's see. It's as easy as a little tap there. And I can absolutely feel this seat insert moving around. Now, these other ones, they don't feel so bad. This is about as old school as you're going to get. So at the very least, there's one seat that's very definitively loose. I wonder, can I tap on this seat hard enough and get it to spin? Now we're getting into conjecture here, or whatever the right word would be, but I think I could probably get that to spin if I could get a good hold on it. I don't know. Crazy. I don't care. It's got to come out. Now, I'm not trying to be dramatic here, but again, peel back the layers on the onion and eventually you'll get to something good, but we haven't made it there yet. I just tapped these guides out. They fell out. The exhaust guides had some press, so they're fine, but dude, this is insanity. I can't do this. This is the intake guide. That's the top of it. It's supposed to have a chamfer at the top. It engages the valve stem seal. But, oh yeah, I was wrong about how this seal was constructed. There was a cap, like a seal housing that rode on top of this, and it sandwiched the O-ring inside of the valve guide. There was not an internal O-ring groove on this like I thought at the beginning of the video. But this valve guide surely looks like it was glass beaded and reinstalled. Like somebody pulled this thing out, glass beaded the whole thing and shoved it back in the hole. I don't understand what's happening here, but they fell out as soon as I tapped on it. And I tapped on the next one. It did the same thing. I'm sure they're all going to do that. There is some nonsense happening here, and how things can get so bad, but there were some factors on the assembly here that did prevent this literal grenade from actually coming through and causing some serious issues. But here I am on the back end dealing with, I want to call it negligence. This feels really negligent. We could have replaced these guides. They were out. I guarantee these were out. But man, I was getting ready to drill these things to take the press out, but they have no press. Check this out. All right, let's get guide driver. There's an intake guide. I am sure if I pushed hard enough, oh, this thing would fall out, but look at this. Light taps. They are not supposed to do that. I can literally, push this thing through. What is going on here? I am disgusted. Oh, well, let's get the rest of them out because it's not staying that way. I know I needed to get this thing welded, but another thing I had to do was get parts ordered. So I'm on the phone with SI, who I get most of my valve guides from. He says he has a few of these left. They're no longer in his catalog. He has 11 intake guides, 15 exhaust guides. See that's normal. That's what it's supposed to feel like. So cylinder 3, cylinder 4, just like the valve seats, we've got press issues. I'm almost tempted to pull those intake seats out. I don't know what's going on here. That's press fit. That feels right. A little loose, but I wouldn't think twice about whether or not there was a press fit issue. And that looks a million times better than the ones I removed. It's a lot shinier. You can see that there was an actual press fit here because that pattern indicates that this was nice and clean. See how matte and dull the finish is on that intake guide? That thing was loose in the bore. So I'm wondering if the bore itself is damaged. So I really hope that the new guides, when I go to confirm dimensions, actually are a little bit larger than they're supposed to. Usually that's what SI does. Okay. So more than likely it's just cylinder 3 and 4 that had no press fit. That feels loose. Fairly loose. That feels correct. One left. Cylinder 1. Hear that? It's so much more positive. So again, cylinder 3, cylinder 4. What is going on here? That's what it's supposed to look like. Interesting. Do I pull these intake seats out? Do I pull all the seats out? What do I do? Let's get these exhaust guides out. Normally on something like this, I would have to core drill the guide because they'd be locked in there and you don't beat on it. If you beat on the valve guide, it's going to expand, lock itself in the bore, and if you keep committing and you force that guide through with this great big bulge on the end of it, you're going to damage the parent bore. You're not going to be able to put a new guide in. And even if you did and were able to get a press out of a new guide, you're going to screw up your valve job or your alignment so badly, you've just ruined the head. So we'll see if the other ones come right out. Cylinder 4 came right out. That's solid. I'm not going to do that. Solid. Solid. So inconsistencies on valve guide installation. I'm going to have to core drill those. So we're going in the machine with that. Okay, let's try to get this thing prepped for welding. So I file tested these inserts. They feel pretty hard. Drug a knife across it. Again, feels pretty hard. They're magnetic as well. Tin is not magnetic. I think these are steel or stainless steel. So I'm just going to be very careful when I'm welding next to them. I might not even go right up to that edge. I'm just going to go shy of it. I think that's the best move. I don't want to damage these cups. If I do, I'll be making them. I don't want to do that. Oh. I think that's all I'm going to grind out. Now, people freak out when I do this. It's pretty common, but I like to DA the flat surface around the weld repair. So that's going to expose fresh aluminum, and it's a very non-invasive way of doing that. I mean, your other options are grind on that surface, sand on it, or file, whatever. This is just a quick and easy way of cleaning up that deck. The fact that I'm welding on this thing is already imperfect. A little bit of damage from the DA sander, not going to be the end of the world. It's getting resurfaced anyways. I'm causing damage by welding on it. Who cares? This is how it's done. Let's set up to weld. I'm going to try to shoot an arc shot, so you might see how nasty, gross this thing is. All right, I'm looking forward to this. I just put a fresh grind on my tungsten and then polished it with a piece of Scotch-Brite. I'm using an Everlast Typhoon 230, which I recently purchased middle of last year, and it's got all the nerdy TIG settings that I really nerd out on and really care about. Well, that's one of the reasons I bought this machine. I'm going to be welding at 180 amps. I might turn it up. I don't know yet. I'm also using an advanced pulse setting, which is every other AC waveform. It's going to feed in a bit of DC negative, which is like what you weld on steel. And that's going to be 100% heat input. So it prevents me from having to use a larger machine or more amperage, and thus putting less heat into the part itself. Now, super high hertz, very high pitch. It's going to be a little annoying. AC balance, so how much DC EP or DC positive I'm going to be putting into my AC waveform is going to be 40%. Pulse time 60%. Pulse frequency is 4.4 hertz, and 100% of that 180 amps is going to be inputted when it goes into that DC waveform using that pulse setting. So it's going to be really interesting. It's not the prettiest weld. It's going to be very dull because I've got a lot of cleaning action that's going to frost the weld, but I don't care what the weld looks like. I want it to be clean, and I want to put as little heat as possible into the part. So I'm going to get this set up on a tripod, and we'll start welding, see how this is going to go. Ooh, nasty. Well, these things are nasty. Lots of holes. I'm going to peen this weld down. I just washed this area around without any filler, and it's dirty. I'm going to grind it back again and then add some metal in. I don't think I need to pull out the helium. It'll weld a lot cleaner with the helium, but I think if I just weld these be very careful and peen the weld down, it'll come out really reasonable after welding. I don't need it to turn out perfect. Even if there's a few specks of porosity, it'll be fine. It'll be a lot better and prevent a water leak into the cylinders. So we just need it to be reasonably clean and flat. So as long as we can do that, we're doing our job. So the next thing I weld will be an arc shot. But I just wanted to show I came back in there and added a little bead of weld right in that edge. Hopefully I can prevent there from being a gap. This is not actually a tin cup. It is what I thought. It's some sort of steel, probably some sort of stainless alloy. I did melt the edge of that cup a couple times, and it looked like it looked a lot like stainless. So I'm a lot less worried about welding around these areas. I'll try to get an arc shot of this. It's really nasty. This by far, this post-war era aluminum is very, very gross. And it doesn't help that I'm already welding something that's a very far derivative of aluminum because it's already been rotted by calcified, gross water. So we'll get there. She will run again. So the first pass, I'm just washing everything around without any filler. I'm going to attempt to boil up all this crap, and you can see it's all bubbly, nasty. The problems with this casting are well beyond the porosity. The casting itself is just really dirty. And then I get into these really clean areas that are awesome. And then I find these problem spots. So what do? I don't know. Do you keep grinding, or do you try to make it wet in and clean up nice? That's a debate that I've always had. I'm gonna stop here once I get this clean. I'm not getting any black bubbles. You see this little black speck floating around at the top? That's about all the contaminant that I'm pulling up here. So that in reality, the casting's really clean. Now the reality is the casting itself is really clean, but it's porous and it's dirty. I don't know if that makes any sense, but no amount of grinding I'm going to do here is going to make this thing weld cleaner without pulling up all those bubbles. I suppose if I ground down deep enough, I could get this thing to weld a lot cleaner. And the only reason that would be is the only reason for that would be because I've ground down deep enough, and now my filler rod is the new material, and that's an option. But since I'm welding next to a feature, which is this pressed in water jet or squirter, I don't want to do more damage than I have to. So I'd really rather have this weld be a little porous if it's going to be porous than sit here welding, causing more damage to things around this. I'd rather have a hole or two or three than a soft head or a damaged head, than a dimensionally compromised head. So I'm going to grind this back, start welding on it. It's going to be nasty, bubbly again, but we'll start adding filler in, and it'll be whatever it's gonna be. I'm gonna peen the weld down at the end, so I'm gonna smack it with a small hammer until I get that weld relatively flat. That's gonna help compact all those bubbles, and it'll come out reasonably well at the end of that. So, and then that'll add some material density to the casting as well. I'm using straight argon. I've turned the gas flow down to about 15 CFH. I've got an 1/8 inch serrated tungsten, nastiness. I'm going to add 47 filler rod into this. That's a high silicon variant of 4043. The more silicon that you add into the filler rod, the cleaner it's going to weld and the harder the weld will be. And I've got my torch tilted away from that cup as best as I can. I'm just going slow. The torch angle isn't really ideal. Going back over that little speck, on occasion you'll see the black dust come up, or you might even see a spot of porosity come up on the back side of my arc because I've taken away the gas coverage, and that's because of my angle, my torch angle. But I'm trying to keep the arc away from that stainless cup. See that? We just pulled up a little porosity. Be patient. I can feel this head getting hot. It's not a race. It's not a beauty competition. I'm just trying to put metal back into the head. Gross. Oh, we're getting a bit hot for my comfort, so let's wrap this up. So that's a weld. I'm going to let this sit here for about 10 minutes. There's more welding to do. But I want to let the heat spread throughout this part. It doesn't matter if I take 20 minutes from weld to weld. I don't want this thing getting over a certain temperature. It's quite warm right now. That pulse setting's really weird. When I actually have helium plugged into this, that will ball the tip. If I was running straight AC without that DC pulse, it would also ball the tip, but we're spending so little time on the DC positive that it's still staying fairly sharp. When I sharpened this, I ground it to, I want to say, a 50-degree angle, 55-degree angle, and then I had a little flat on the end. So now we've moved on to a different area of this head. This is just straight up aluminum. No stainless cup, no anything that's going to be real sketchy here. So I think part of the issue with the other spots was that we were welding next to that stainless cup, and I think we were picking up garbage from the back of that insert, and it was just going up into the weld, and it wasn't helping the situation, to say the least. I already lit up on this section, and it's significantly cleaner. The only nasty portion was right here, and I did grind it down just a bit further, but I'm not too concerned if it fights me just like the other ones did. But the rest of it cleaned up very nice, or it puddled up very nice. So let's put the lens on, see what this weld's like. I did clip the mic to my helmet, so hopefully that makes an improvement on the audio. See all that porosity? Now what I'm going to do, I'm going to blast this with some heat and just walk this porosity around, see if I can get it to play nice. Whoa. Gross. Sometimes it be like that. And it's very much cleaner over here. Only time I pull up a bubble is when my arc length gets a little out of control. Let's feed some metal into here. See if we can get this to work a little better. Start here. Come on. There you go. Gross. Very gross. This rod angle isn't ideal, but I do want to travel backwards here. I think it'll help with the distortion in the casting. It doesn't hurt to change directions. So if you notice, sometimes when I add metal, there's a black little layer of gunk sitting at the top of the puddle. I'm not progressing until I see that layer disappear. Your chances of this weld being clean and proper when you go to machining is significantly higher if you don't rush these steps. So that's all we care about, really. I don't really care what's happening on the way up to the point of machining. From experience, this is probably going to be okay. I'll probably set this up in my machine. It's too long for me to cut in my mill, but I'll be able to cut the welds off and get an idea whether or not it's going to turn out fine when I finally do the final surface. I ran out of filler rod there. I'm gonna do a restart. Gonna do one more pass, stacked up on the edge of these welds, and then we're gonna fill in this little low area. You see all that black nastiness? That's what I was talking about. Don't progress until it cleans up and stabilizes. Let the AC do its job. So that's everything welded up. I think I've got enough metal added into here. Gonna have to cross drill or fix this cross drill. So this is what I wanted to show you guys. I'm actually peening these down with a ball peen. I'm going to compact these until they're relatively flat. Now that's going to add some density to the metal. It'll help out if there's any porosity, and overall, it's just good for the casting. And it doesn't relieve stress in the casting. That's a common misconception. That a lot of people think that you're stress relieving when you do the peening process, but it's actually just redistributing the stress throughout the casting. So it keeps things that are under tension. Your casting's doing this number, especially right after you've done a bunch of welding on it. It kind of helps it relax a bit, but there's still tension there. So doing what you can to keep that in check is super helpful. And then in addition to that, after you lop off the weld during the resurfacing, that also changes the way that the welds affect the casting, and that's honestly more of a stress reliever than the peening or anything else you can do. So everything you do affects another thing. I forgot that I have the option of bringing a gun to a knife fight. And that's what that's going to look like after the peening. Now, it does distort everything around the peening, and depending on how hard you've pushed it down, you pretty typically would expect low areas directly around the weld. It seems that this deck is quite thick, so I really don't know what it's going to look like after surfacing, but I think I'd at least take another 10 thousandths off of this deck. So I just have to be conscious and be careful to take as little off as possible off of this head, because it's already been rebuilt at least one time. I'm finding more and more issues with this thing. I want to be as minimally invasive as I possibly can. Okay, so it's a couple days later. I was going to cut the video right before I finished the welding, but I had a couple issues. I couldn't sleep at night, and I decided I was going to put a test cut on this head before I brought it to RPM and then use their machine to cut the full length of this. But what I discovered was there were a few bits of porosity all throughout the welds, just along the edge of the weld. The material I put in had been pretty decent, overall pretty clean. But I knew that I needed to come in and do some touch-up. Well, I started doing that, and it was the same situation. I started cooking out more crap, and it's really just a problem with the casting. It's a dirty pour. You're going to sit there and fight and fight and fight and just heat soak the part if you want to get it perfect. Now, I talked to a friend of mine, Nick Smithberg, really, really great cylinder head guy out of Nebraska. He reached out to me. He goes, "Hey, I know what you're fighting. You're not going to fix that. You got a problem. He calls me up. So gracious of him, too, because he called me up in his own free time. He wasn't, he was literally not at work in his shop. So out of the goodness of his heart, give me a call. He said, hey, let me tell you something about this. So he walks me through and he says, hey, change your tungsten. This is what you're going to want to do. You're going to have to blast a bunch of amperage into the head, puddle up that base material, and then you can add in your filler rod. But I also built upon that, changed the tungsten, and came back in and hooked up my helium tank. And if you've followed me on Instagram, you'll know that I have a real problem with using helium right now, specifically because my K bottle cost me $780 to replace. Let me show you what I got going on. Now, this thing, not approved, it's just sitting there, just ignore that. Assume it's strapped into place. This is 100% argon. Okay, this is getting quite spendy these days, but it's still quite affordable. $180 is what this cost me. 6 years ago, this was $70 to buy. But now, times have changed, I guess, especially since most of our helium is imported from Asia, and I think some parts of Europe. This stuff is a product of the mining process. I've got a half full bottle here, $780 to replace this thing. And most of the time, I mean, I can get it, they'll sell it to me, but most of the time, you walk into a California gas supplier, they're going to laugh at you if you go and ask for helium. Every single time, without missing, they laugh at you. They go, you sure you want that stuff? I go, yeah, I want that stuff. All right, basically $800. You gonna give that to me in good old American greenbacks? I go, yeah, I guess so. And they have no shame. This lasts 6 hours on my typical welding settings. A lot of times recently I've been running it on straight helium. I used to tee this in at 25%, 75% argon helium, just using a tee. That really was not the best way to do it. It was the best thing you could do was just order it already mixed. But when you order it already mixed, they charge you for whichever is the most expensive welding gas, which is the helium. So you're getting less helium and you're still going to pay $800. Recently, I was in a bind. I learned that my Everlast machine, since it runs on an AC setting with a DC negative pulse, I can run straight helium. Where typically, if you're going to TIG weld aluminum with straight helium, you're going to be running it on DC negative, no cleaning action. That's its own video for a different day. But this thing, straight helium, DC pulse, actually really, really awesome. So I'm gonna go show you what I just did. I came in and just brute forced this thing, no setting changes, and it's way better. And I'm still cooking up shit. I am. But I've got so much more horsepower. It's not a problem, and I'll bet you that it'll surface a hell of a lot cleaner. Now, if you don't know, straight helium on helium is cheater, or a straight helium on aluminum is cheater mode. If you've got a small machine, you may as well have an extra 100 amps with the helium. It just adds more energy to your arc, and you're going to puddle up on that material immediately. Not necessarily, I guess you could if you wanted to, but it doesn't necessarily add more penetration to the weld, but there's just some kind of reaction with the arc, and you're instantly lighting up on that aluminum. It works awesome. And so far, since I started using straight helium, and I should have really, from the beginning here, just used straight helium, it would have been so much faster, and I would have saved myself a bit of headache. But dude, I've got this calculated out. That helium bottle cost me something to the effect of $2.98 a minute to use. I have a problem with that. So let's go do an arc shot. I decide I'm gonna touch up a couple extra areas. I'll show you a little arc shot of that. It's gonna go fast. It's gonna go quite wild, and you'll laugh at me for not for deciding to be a cheap ass and not doing that from the beginning. So with no other changes, I promise you no cheating here. Look at that difference. I'm still boiling up garbage, but this is a completely different ballgame. That's a lot more typical of what you would get with a regular caster. I gotta remember to dip more intentionally using helium. It heats up that shielding gas so quickly. The issue with helium is the arc is a lot more unstable. And it's much, much less defined and controllable. So look at that. I should have done this from the beginning. Much better. And stuff like that that'll make you feel like you've never welded a day in your life. It's a different look. It's a much different look, but that came out really clean. And I'll bet when I run that surfacer, that fly cutter across, it's going to be a night and day difference from how I had it welded up originally. It's going to look good. I'm just going to cut these welds off. It's already looking a lot cleaner. Let's see if that's actually the case. Oh yeah. Big improvement. Now, more than likely, there's going to be a few little spots, but I can accept a couple little things, especially if they're not in a place that's going to hurt anything. So far, so good. Now, I wish I had a longer table here because I'm about 2 inches too short on both sides. I only have a 42-inch table. If I had a 48-inch table, I'd be able to surface this head. Now the surface is roughed in. I had to come in and touch up a couple more spots because it's still not exactly perfect. But I'm at the point now where I'm going to actually call this usable. Because while there are a few spots of porosity, they're not going to run into anything that's important. They're just going to live in little areas covered up by the head gasket. None of the porosities running over the actual fire ring or the sealing ring of the head gasket. So I'm very happy with how that turned out. So especially since there was literally just no material here supporting the head gasket, that just allowed water to leak onto the deck in places where it wasn't supposed to go. And now the head gasket's actually going to be able to do its job. this is going to be a bit of a project. I'm actually considering the thought of pulling these intake seats out and replacing them as well. So I'll have to ponder on what exactly I want to do. But now at this point, I'm ready to pull this head out of my machine, and I can go drive it over to RPM, put a final surface on it, and then I'll just be sitting here twirling my thumbs, waiting for new valve guides to come in. Hopefully they come in sooner than later, because I want this out of here. Plus, I was told that the car is really cool, so I'd love to drive this down and check out the car, and I hear that he's got a bit of a collection, so while that sounds interesting, I do want to see a Gullwing up close, especially one that I've worked on. I think this one's going to end up getting put on the wall of cool things. So I would say that's about it. We'll come back to this project. This is a lot of fun for me. So this is where we're going to put a pin in it. So thanks for watching. Leave me a comment. Let me know what you think. Appreciate you staying until the end. And this is Josh at Engine Rehab. I'll see you later.